Hello, everyone, and welcome to another command prompt demonstration. This is the third in a series of videos about Citus, and today we are going to be covering the execution of Citus data across nodes. I'm your presenter. My name is Zach Tedder. I am an engineer at Command Prompt, and over the past year, I've been doing a deep dive into Citus, and I'm excited to share with you how we distribute data horizontally across nodes instead of vertically up in the same machine. So let's talk about what we've covered previously. On the first video, we covered an overview of Citus as well as installed Citus onto our machines. In the second video, we did a configuration of Citus. So we altered the settings in PostgreSQL conf, PGHBA conf, and we set up PGPass. Today, we will be covering the best practices for choosing a distribution column, and we will then execute some data across nodes, and then take a little look-see at some shard information. So when it comes to choosing a distribution column, you should understand that this is perhaps the most important aspect of planning a Citus cluster, because it's going to make sure everything functions smoothly and how we want it to. Our intent here is to group related data together on the same physical nodes and make sure that our queries continue to be fast, as well as adding support for all SQL features. The practice of doing this is called co-location. We are going to be tactfully dividing data up to keep the related data on the same machine, or as Citus calls it, a node in this case. The ways of practicing this for multi-tenant applications use the term tenant ID, and some common examples of that are company, account, organization, or perhaps customer. Real-time applications use the term entity ID, and the most common examples of that would be users, hosts, or devices. So when it comes to the best practices, what we're trying to do here is retrieve data from one node at a time with our queries. So again, that's why we're isolating the important data to one node, is just to prevent this cross-traffic talk and keep our queries very quick. So what we want to do is create these small, meaningful blocks of data with columns that are frequently used in group by or join queries. And we also want an evenish distribution among the worker nodes at all times. So you don't want some worker nodes that have a lot of data and others that have very little. So one's working way overboard while the other ones aren't doing much. So it's also important to note that if multiple tenants share the same table, that it's important to not distribute this table across all nodes, but just distribute it to each node as a reference table so that the references can be very quick along with the other data. Another important note is for real-time and time series data, you do not want to use the timestamp as a distribution column if you don't have to. If you must, Citus recommends using standard partitioning for time ranges instead of the timestamp itself. So something like a range of weeks or months. And we'll go over shortly of why that still can be very problematic. Okay, so let's understand our schema before we decide on what the distribution column is. This is an example table that tracks sales across a number of different stores. So our table name is sales, obviously, and we have a transaction ID column, as well as a total cost column, a date time column, and the store ID column. So let's talk about each of these individually and break it down. The transaction ID column is not going to group enough data together very well. It is a unique primary key that separates each sale, but it's not going to be great at grouping transactions at the same store or in any other really meaningful way. The total cost column will also not group data together very well. There might be some occurrences of the same cost, but it's not likely that these similarities are going to provide very meaningful data. And now we come to the date time column. So this is a timestamp column, or a timestamp type, I should say. As we previously just discussed, that's not a great idea to use this as a distribution column. It is possible to group the data using partition data in this manner like we were talking about. However, at any point in the day, data is only going to be ingested into one node. And, as far as sales go, there are heavy times of sale and heavy days of sale. So it's not going to be very evenly spread out. And this is potentially going to lead to skewed data. On top of that, any queries across time are then going to cross nodes, which again, we're trying to prevent. We only want to query from one node at a time if we can to keep everything functioning quickly and smoothly. Okay, so that brings us to store ID. This column is going to group data together the best. It's going to group well across servers, as most of the queries are going to be isolated to data about individual stores. It's also going to be a consistent distribution column that can be added to other tables for co-location. And if you'll notice down at the bottom, I added store ID to the primary key list because we're going to need that there in order to then distribute our data on the store ID. So now we've come to executing our data across nodes. First, we're going to create our table, then we're going to load some data into it, and then we are going to create that table to be a distributed table. We're going to do that on the table name and then the distribution key. So in this case, the table name will be sales and the distribution key will be store ID. Then we're going to confirm that the data has been distributed to each worker. And then we are going to clean the coordinator node of the original data, which has now been distributed in shards. So if you'll recall from our previous discussion, the coordinator node should only contain metadata and the production data should be on the worker nodes. So after we distribute the data from the coordinator node to the worker nodes, we want to then clean that data off of the coordinator node so it only contains the metadata and no production data. So let's hop in. We are here in our coordinator node, and this is an LXD container. So in our coordinator node, we want to go to our previously created demo database. And from here, we are going to create our table. This is the same table we were just talking about on the slide. And now we're going to throw some sample data in here. And we'll just go ahead and select everything from sales. And we see that we have inserted it correctly. Now let's take a quick hop over to our first worker node. We're going to select everything from sales. And not only do we have no data, but the relation doesn't even exist. So let's come on back over to our coordinator node. And from here, we are going to then create our distributed table. And we are doing that with the sales table. And we're doing it, the distribution key is going to be our store ID as we previously discussed. And there we go. We have distributed our data. So let's hop over here and make sure. We're going to use the same command. And there we go. We can see that we have access to our data over here on our first worker node. So let's come over to our second worker node and make sure that this one has access as well. There we go. So we can see all our data from both nodes. That doesn't mean that all the data is on both nodes, but both nodes are able to query it because it is now a distributed table. Okay, back on our coordinator node. Again, since we've distributed the data off of the coordinator node, we now want to clean the data off. And you can do so with this drain node command, but Citus also provides this wonderful command after distributing data to make it really simple to then go ahead and clean up the coordinator node. Excellent. So now that we have distributed our data, let's take a little look at some of the information contained in the metadata about our Citus cluster. The Citus shards will contain, amongst other information, it'll contain our table name, as well as the shard ID, and then the node name and the port associated with that node. And then it'll tell us the shard size as well. And pgdistshard will tell us how Citus chooses tenant distribution. As you can see, it also has the logical rel ID, which is the table name. It's got the shard ID and shard storage. In this case, T means table and not true. But more importantly, you see the shard min value and shard max value. Now, what these are hash token values assigned to each piece of data inserted into the cluster. So when the data contains a hash token value within this range, it will be placed in that shard. So let's hop in and take a look at this a little bit more closely. So we're going to select everything from Citus shards. And here you see the full output. Now, first thing to note is that this has 32 rows. Citus by default will make 32 shards when you distribute a table unless you specify otherwise. But we have our table name here. It's all sales. We have our shard IDs, and then we have the shard name, which is a combination of those two. And then we have here the Citus table type, and this is our distributed table, but it could also be a reference table. And then we have co-location ID. They're all one because it's all the same table. Then we have node name, and you see it's alternating between worker 1 and worker 2. And then there's node port, which is the port associated with that node. Then we have our shard size. And if you'll see over here, there looks like there's only 3 pieces of data. But let's go back up here and we can see that the store ID, there are 3 with the store ID of 1, 2 with the store ID of 2, and 1 with the store ID of 3. So there's only 3 different store IDs. So there's only 3 shards being used with data on them right now. Okay, now that being said, let us take a look at pgdistshard. Okay, so again, we have these hash token values. Back up here, we can see that this shard, 102009, has some data on it. What this table down here tells us is that that data will have a hash token value between 2,013,265,920, and that was a negative, between that and negative 1,879,048,193. It's a mouthful. Anyway, that is how Citus knows where to place the data. All right. So what we covered today was best practices for choosing a distribution column for multi-tenant software as a service applications, as well as real-time analytics. And that includes time series data. And then we distributed some data across nodes and took a little peek at some of the shard information to understand better what's going on underneath the hood. Thank you all so much for your time. Let's continue this conversation in the comments with some questions or concerns perhaps that you might have. Thank you for your time again.